This video is about analyzing data. As you know, data management is the process of collecting, displaying, which we've talked about, and now finally analyzing data. We use the mean, median, and mode, as well as the range and standard deviation to analyze data. The mean, median, and mode are measures of what we call central tendency, and that's because they provide information on the center of the data. The range and standard deviation provide information on the spread of the data to indicate how the values of the variable compare with the mean. Together, we're going to look at the process of how to find each of the statistics, okay? And you should have seen some of these definitely before. Okay, the first one is the mean, otherwise known as the average. Okay, and basically what you do is you take the sum of all of the values and you divide by the number of values. Okay, so add them all up, divide by how many there are. Like I said, you've probably done this before. Now, in terms of mathematical symbols, it's actually a little curvy X or an X with a line above it that's used to denote the mean. And what we do is we take the sum, so there's this sigma symbol of all of the values, and we divide by the number of values, okay? And we'll apply this to some examples in a second. For the median, you might have seen this one before. You put the numbers in order from least to greatest, and you find the middle number. Now, one quick note, of course, that if you have an even number of values, you take the middle two values and you actually find the average or the mean of those values. Okay, so the next one is the mode. And this is the value that occurs most often. Okay? So the range is the difference between the greatest value and the least value. And the standard deviation is the most complicated one. Okay? So I'm going to lead you through this process. The first thing you're going to do is find the mean, find the average of all of your values. Okay? The second step is what's a little bit complicated. You're going to subtract the mean, that's the symbol, right, from each data value. And you're going to square it. So put it to the exponent of 2. You're going to square that difference that you subtracted. Okay. Next thing you're going to do is you're going to divide. You're going to take the sum of all of those and you're going to divide it by the number of data items. So you're going to divide the sum by the number of data items or values, same thing. And last thing you're going to do is you're going to square root the result. Like I said, I'm going to lead you through this process. Okay, so as a formula, this can be written using an S for standard deviation. Okay, so first thing we're going to do is we're going to take each data item and subtract the mean. Okay, we're going to square it. We're going to take the sum of all of those values. We're going to divide it by the number, and we're going to take the square root of the entire thing. So that's the formula for standard deviation. You wouldn't need to memorize that. That would be the kind of thing you would put on a crib sheet if you were doing something, or you would look up that formula to remind yourself. Okay, so what this is this is an average of how spread out each value is compared to the center of data, meaning the mean, the median, or the mode. Okay, so just make sure you got that down, and we're going to try some together. Okay, so here's the example. For a game of basketball, a group of friends decide to split into 2 randomly chosen teams. The heights of the players are shown in the tables below. We're going to calculate the mean, median, mode, range, and standard deviation to compare the distribution of heights for the 2 teams. So the first team we have here is the Falcons. And then we also have another team down here called the Ravens. And we're going to calculate all of those values for each set of data. So we'll do the first one together, and then you'll pause the video and you'll try to do the second one on your own. Okay, So I've created these extra columns to help us do some of the work. So one thing we definitely want to do right off the bat is we have 7 players, I believe it is. So we definitely want to calculate the total of all of their heights. So go ahead and punch that in. You should be able to, of course, do that on your own, and you should get 1,155 as the total. So we are going to need that. The other thing that we're going to need, and I'm going to put in this column right here, is we're going to need the data sorted from least to greatest. So go ahead and put the data in order. Looks like the least height or the lowest height is 146, and you pause the video and finish the column. Okay, so there I have my sorted data. So using all of that, I can figure out all of my measures of central tendency. Let's start with the mean or the average, right? So we're going to take the sum of all of the data, divide by the number. So in this case, it's 1,155, and there are 7 basketball players, and therefore then our mean is 165, okay? You check that on your calculator if you're feeling unsure. Okay, mode, we're going to look for the one that occurs the most often, and there are no repeats, so there actually is no mode for this data. Okay, the median, we're going to look for the middle value, so that's this value right here. There are 7, there's an odd number, so it's easy. So our median is 165, which actually happens to be the same as the average in this particular case. Okay, so note those are the same in this case. The other thing that we can do right off the bat in this case is we can find our range. You just take your highest value, 183, subtract your lowest value, 146, and that tells you that the range is 37. Okay, so there's all your measures of central tendency, as well as your first spread, which is the range. Now we're going to work on the standard deviation, which is, of course, most complicated. Okay, so I've created this extra column for you. What I want you to do here is I want you to do this part. I want you to do x minus the mean squared. Okay. So in words, what we're going to do is we're going to subtract. We're going to do the data value. We're going to subtract the mean, and we're going to square the result. Okay, and I'll show you my work for all of them. Once you get the hang of this, you might be able to do some of the work, the beginning work in your head. Okay, so our data value in the first row for Laura, she is 183 centimeters. We're going to subtract the mean, which is 165, and we're going to square the result. Okay, following BEDMAS, we're going to do our brackets first, so we get 18, then our exponent squared, which is 324. Okay, Jamie is 165 centimeters tall, so we're going to do 165 minus the mean, which happens to be the same, and square it. So that gives us 0 squared, which is, of course, 0. For Deepa, we're going to take 148, subtract the mean of 165, and square it. So that's going to give us negative 17. It's squared, so it actually doesn't matter that it's negative because it always becomes a positive, and that's 289. Okay, hopefully you could actually pause the video right now and continue the column and check your work. But I'll keep going. We're going to do Colleen, 181 minus 165 squared is going to give us 16 squared, which is going to give us 256. Ingrid is 178 minus 165 squared is going to give us 13 squared, which is 169. Justice is 154 minus 165 squared is going to be negative 11 squared, which is 121. And the last one, Sheila, is 146 minus 165 squared is negative 19 squared, which is 361. Okay, so hopefully that made sense there. Now we are going to find the total of that column because we will need the sum. Okay, again, punch them all into your calculator. You get 1,520. Okay, so here we go with our standard deviation, S. Our formula is we're going to take the sum of that column. We're going to divide how many there are. and we're simply going to take the square root of the whole thing. Okay, so the square root of the sum of that whole column is 1520 divided by 7. Punch that into your calculator, and you should get 14.7 centimeters. That tells you how spread out the data is. Okay, so there are all of your measures, all of your analysis that you need to be familiar with. The standard deviation, of course, will take some practice, but hopefully the rest of it makes sense. Okay, so your task is to try this next example on your own, and then we're going to talk about some of the comparisons. So pause the video, see if you can fill in the information, and then just replay the video for yourself so you can get some of the details, and we can just talk about the comparisons between the two teams. Okay, so funny enough, our mean is exactly the same. Our mode, as you can see, this one has a mode. It's the most common value, which is the 166. The median is the middle value, which also happens to be 166. Much smaller range. We're just taking 168 minus 161, and so our range is 7. And then I'm going to go on to our standard deviation. Easier to do this one in your head. So for the first one, for Sam, I'm going to take 166 and minus the mean, which is 165, squared, which is just 1 squared, which is 1. Shannon, 163 minus 165 squared. It's going to be negative 2 squared, which is 4. 168 minus 165 squared is 3 squared, which is 9. 161, 65 squared, negative 4 squared, which is 16. 165 minus 165, this is our 0. 166 minus 165 is 1 squared, and the last one, of course, is the same. Okay, so here I get my total. I get 32, and so my standard deviation is my sum of this column divided by the number, all square rooted. So the square root of my sum, which is 32 over 7, and so my standard deviation is 2.1 centimeters. Okay, so if we're comparing the data, one thing to note is that the average height of the girls on both teams is actually the same. However, the heights on the Falcons are a lot more spread out, right? The heights vary a lot more on the Falcons compared to the Ravens. Okay, so you're going to go ahead and do some practice on this.